Well, happy Monday. Today is um, start of testing week and solar eclipse. Hopefully, you guys will be seeing the solar eclipse. Hopefully, the weather is nice where you are. And your birthday. Wow. So nice. And you're gonna have to wait 100 years for the solar eclipse to happen, and you're in Ohio again. So it's a good thing you got. It's a very memorable birthday. Happy birthday, Gabby. So good to see you all. So we are starting thermal energy, and here is the link to. Yeah, the next one in the United States is 20 years, but they said it's going to be 100 years before it's in the same spot of Ohio, like Ohio. So that's what Google says. So I'm taking that as gospel, so to speak. So let's do some vocabulary work on thermal energy here. Hey, Josiah, good to see you. And Chloe, good to see you as well. Dylan, if you guys can get in there or hop in a little bit later, we're going to go over some vocabulary here. And because we are on a new unit on thermal energy. Thomas, good to see you. And Aliyah, all right, good to see you as well. So if you guys will pop into the quizzes link, yeah, 100 years seems like a long time. 20 years somewhere in the United States, but people chase the eclipse. Whoever has the money can go and fly to eclipses all over. I think that there's quite a few of them during the year. Hey, thanks getting in there for Thomas. Good job. I'm going to get started, you guys. Let's take a look at what we got here. I'm going to turn my camera off as we do this. All right, so specific heat is the amount of energy required to raise the temperature of a kilogram of material by 1 degree Kelvin, right? So basically, what we're looking at today is um, some take very little heat to do it, and some take a lot. So that we call that specific heat. We'll be talking about that this week. Good job, guys. If you can get in here, ladies and gentlemen, that'd be great. All right. Thanks, Jessica, Josiah. Thanks for getting in there. All right. So thermal equilibrium, where things are equal on both sides of an equation, let's say. All right. So it's when two objects reach the same temperature and no longer flow between them. So warm temperature moves to cold temperature. And notice that 100 degrees goes to 0 degrees. And then we have an equilibrium of 50 degrees where they stop changing the temperature here. So, all right. Thank you guys for getting in. All right. So, what's the main difference between heat and temperature? All right. Heat is the measure of the total energy, and while temperature is the measure of the average molecular motion. So it's the first one in there. So heat is the measure of the total energy, and molecular and temperature is the average molecular temperature. Okay. All right. Question 3 out of 14. All right, which is not part of the kinetic theory of matter. So we're going to be talking about the kinetic theory of matter. And it is occasionally particles stop moving, but it's part of it is matter is made of tiny particles. Particles are always moving in random paths, and the type of movement demonstrates the amount of energy it has. So it's occasionally stops. Occasionally stops. Okay. So if you look in today's vocabulary, um, so a matter is made up of blank that are constantly moving. So particles, right? Particles um, are constantly moving, right? I don't know why we have pieces of plastic in there. Thanks, Thomas, Chloe, Gabrielle, and Josiah. The computers can make a big difference on whether this quizzes will work or not. So, and the Wi-Fi. So, what defines heat? Right. So, thermal energy flows from warmer places to cold places. That's what defines heat. Warmer places to colder places. So, if you have ice in your hand is moving energy toward the ice. It feels cold to you, but it's actually moving in that direction. All right, freezing point of water. Anybody know what that is? You might have to type it in there. But the freezing point of water in Celsius is 0. Celsius temperatures go from 0 to 100. For boiling is 100 and freezing is 0. It's used by the scientific community. It's easier to use than any other ones. Where Fahrenheit, what we're used to, it talks about temperature in 32 degrees for freezing, 212 degrees boiling. But we use it still in the United States. Still use it in the United States. So, as I said, what's the freezing point of water in Fahrenheit? That's 32 degrees. So, we're probably much more familiar with that. The reason that we have these scales is because back in the day, when people were selling thermometers, this guy named Fahrenheit built a good thermometer and he made his own scale, and people said, hey, it works, it's very reliable, we'll keep buying these. So we haven't lost that yet. So if you make something, you can do this. What happens when water is at 0 degrees Celsius? Remember, that is, if it's getting colder, it's we're losing, if we're taking heat away, it's freezing, right? 0 degrees freezing. It's also the melting point, but it depends on if we're adding heat or subtracting heat, right? So that's freezing. Question 10, we got 5 more to go. The temperature scale mostly used in the United States with 32 degrees for freezing, 212, is the Fahrenheit scale. That's where the F comes from, right? The Fahrenheit scale. And here's something that physicists use. The absolute coldest anything can get is in Celsius is minus 273.15 degrees or 0 degrees Kelvin. That is called absolute zero. That's the place where movement of molecules stop altogether. So movement stops, right? All right. So a particle in a system takes in energy is called energy absorption. If you look at this picture, 19% of the sun's energy gets absorbed by clouds. Energy absorbed in the surface is a much more. And again, it also depends on the color of objects as well. So the darker they are, the more energy is absorbed. That's why you try to wear lighter clothing. All right, so transformation of matter between solid, liquid, and gas. All right, it is a state of change of state or phase of matter. Either one of those works, both of them work. Change of state or phase change. So you can say either one of those, and you can see this example of phase changing from gas. If we warm it up a little bit or cool it down a little bit, becomes condensation. And if we warm it up, it becomes vaporization. All right, last question. Gas to solid is called. Okay, so if you look at this diagram here, gas to solid is called deposition. Deposition. All right, deposition. Okay, so how do we do, guys? Did pretty good here. First, second, and third. We have Chloe third, Rachel second, Thomas first. Good job, guys. All right, so let me show you what's going on here. Let me stop this. Okay. So today we're talking about thermal energy. I just went over some of the vocabulary words that you're going to use. You'll take a look at the vocabulary words in the notes. If you click on the notes here, you got the vocabulary words and definitions. All right. Why we're learning this because heat is really important to daily life, right? Heating water, we do a lot of drying clothes. So what we're really concerned about these days is understanding energy and conserving it so that we don't have too much issues with global warming. All right, who came in? John. Good morning, John. Good to see you. Um, we're not going to have time for a lab this week, but there is a simulation, a PhET simulation in there if you want to play with. Um, and how you know what we're doing today is, of course, understand the vocabulary, convert Celsius to Kelvin, and that's pretty straightforward. Just add 273 degrees to anything that we have in Celsius. All right, so remember state testing tomorrow. Today is half afternoon classes are asynchronous, right? So you can get out there and see the eclipse. Tuesday, everything's asynchronous. I'm not going to add any more assignments to you. Today is the only place we have an exit quiz for. Next Tuesday, Wednesday, Thursday, we don't have Wednesday this week. So for science, at least in my class, so you will have time to do your assignments. I will send recordings to you, like this will be recorded. And I'll be back on Monday, April 15th. I have a small group of people I have to test, and that is just through the week. So many of your other teachers, if they're in Cincinnati, have to test all 3 weeks. So I'm fortunate that I don't have that many, and I'll be back and test you guys live. And hopefully everybody's got their dates to where they're going. I know not everybody's going the first week. Some people are going the second or third week. So you'll be on and off. Uh, um, about 60 minutes. 60 minutes. Yep. Yep. So I'm hoping that I have a problem with a car right now. My car is in the shop and they're supposed to give me a rental, so I have to figure out how I can get over there. And I'm trying right now. Not right now. I tried to call them between classes. They were busy. So I hope that I can do that. I know we'll get like 98% eclipse rate, but I'd like to see what a total eclipse looks like. Thanks for asking, Thomas. So today we're talking about kinetic theory of matter. Kinetic, remember, kinetic means energy of movement. So when things are moving, then they have kinetic energy. And this is from your notes, states that particles make up all matter and constantly in motion and random motion. States that matter of the object will determine the speed and direction. So solids just vibrate back and forth, right? Liquids have more kinetic energy. They move by sliding past each other, and gases have the most and have the highest speeds. And again, everything we'll be talking about specific heats later, but things don't heat all at the same rate. You know, some of the materials we have uh, can gain kinetic energy much faster than other things. So that makes sense if you think about your stove. You have a pan. You want to put a pan on there that's metal because it gains heat quickly. So you want to be able to cook things quickly. So you want to make sure you have something that has that kind of material. So let's take a look at this question here. it says, let's look at water and label using 1, 2, 3 that from, let me do this so I can read this, from the most kinetic energy to the lowest kinetic energy. All right, so which has the highest kinetic energy? Is it a gas, liquid, or solid? And which has the lowest one? So you're going to be going in this direction, right? You're going to go from gases to solids, right? Gases to solids. All right, so that is, so we go gas as the most kinetic energy, liquids have less kinetic energy, and then solids have the least kinetic energy, right? So gas, liquid, solid, right? Gas, liquid, solid. Thanks for getting in there. DeAndre, good morning. Didn't say good morning to you. Thanks, Thomas, Rachel, Gabby, DeAndre, Adriana, John, thank you. Dylan, thank you. Chloe, anybody else in there can get into the chat? Aaliyah, Josiah, Kendrick, are you able to get in the chat? Put in your vote. Okay, so we decided that was letter C, right? Have the most energy is gases because there's more kinetic energy. You can see that, right? All right, got 8 out of 14, better than last hour. I had like 3 people. They are just so tired. So what is kinetic theory of matter? Because particles move at various speeds, each particle has its own kinetic energy. And we measure using a thermometer. The thermometer measures the average kinetic energy. And the reason that we say average is because if we put a thermometer in a liquid, it might, these around it might be more energetic, moving around more, and these up here might be less. Okay, so again, we can only measure the average of those. And a lot of times you have to let your thermometer stabilize, leave it in there a while. But we're, again, most of the time we're pretty impatient, right? So temperature is the average kinetic energy. We're okay, so let's take a look at one of the things that we're talking about. Good to remember is that there's a difference between the Celsius scale and the Fahrenheit scale. Remember, the Celsius scale goes from 0 for freezing to 100 for boiling. Fahrenheit scale goes 32 degrees for freezing to 212 degrees. And again, ever since my days in high school, we've always wanted to use the Celsius scale, but again, science seems to be the only ones using it. So, all right, so of these, okay, so we're looking at Fahrenheit of 32 degrees is the same as Celsius 0 degrees, right? So sometimes you'll get a thermometer that will say that have both. So this one will have, like on this side, we'll have the Fahrenheit scale. This would be the 32 degrees F, 0 degrees here. So what's the average kinetic energy of the temperature of solid ice? 32 degrees, and Celsius is 0. Again, it's much easier to go with 0 to 100. Okay, yeah, that's what I did here. I got to erase some of this. 0 to 100, it's much easier to figure out temperature and calculating it versus 32 to 12. So we're talking about letter C. Everybody got letter C in there? Thanks, Adriana. Thanks, Chloe, DeAndre, Dylan, Rachel, Thomas. How about you, Sophia, Madeline, Chloe, Kendrick, Grace? Good morning. I didn't see you this morning. Just saw you now. Appreciate you coming in. Happy Monday to everybody here. Let's see. You are a heavy cat. And little brother says hi to you guys. He wants to get on my lap. That's where it's warmest. All right. Okay. 7 of you. Excellent. Half of the class is really participating. I really appreciate that, guys. So remember I said that boiling point of is Fahrenheit is 212 degrees, and Celsius it's 100, right? Okay, so boiling point of water, and again, it depends on where we are, right? That's the temperature. So sometimes the boiling point in the mountains is different than the because of the what they call the vapor pressure. So Fahrenheit is 212 and Celsius is 100, right? So that's letter A, right? Yeah, 3 of you guys got it. So thank you guys. 4. Anybody else? 5. All right. So 4 people. Thanks, Chloe. So remember, it's Fahrenheit's 212 to 100 Celsius. So some things that if you this week would be a great idea to take some notes, make some flashcards, put it into your memory banks. It's something that's very useful to have. And then you can put that into offline tracker time. So you got 6 out of 14, right? A couple people maybe walked away. All right, so I'm going to show you this. Let me ask you this question. Do you think you can burn something, light a match with steam? Can you get steam hot enough to burn a match? Tell me what you think is true here. And I will set this video up so we can see this. All right. Where are you? My video, my video. Okay, here we go. Give me what you think if that's true or not. Hot enough to light a match or stays 212 degrees or 100 degrees Celsius? What do you think? All right, so I've got 4 people. Come on, guys, give it a. This is your prediction. This is your prediction. Can we get water, steam hot enough to light a match? What do you think? We got 5 people. Most people are saying stay at 212 and 100 degrees. That's the highest it gets, right? What do you think? 5 people. That's it. All right, 5 people. All right, so let's take a look at this video here. Turn the sound on here. Share this video with you guys. Turn my camera off a minute. Here is the video.
Did you know that you can heat water to 2200 degrees Celsius before it starts to break down? This means we can start a fire with water. To do this, I start by heating some water until it boils. At this point, the water is at 100 degrees Celsius, and I'll need it to be a lot hotter in order to start a fire. So to make my super hot steam, I use a burner and some copper tubing that I bent into a series of coils. The burner can heat the coil and steam inside to temperatures exceeding 700 degrees Celsius. At this point, the steam is completely invisible, but you can hear it shooting out of the end of the tubing. And now it's hot enough to burn paper, light a match, or even cause steel wool to burn.
All right, so thanks for voting, ladies and gentlemen. So you can, if you heat the steam, you can build up that to what they said, 2,000 degrees. So, all right, so let me go back here. So you guys, all right. So just take a look at that. We're going to be done in here a couple minutes. There are 3 common temperature scales. So this is in your notes. The notes are located in the week 11. There are 3 common temperature scales. Celsius goes from 0 to 100. Fahrenheit 32 to 212. And Kelvin is used commonly by physicists. The units are in kelvins instead of degrees. Water freezes at 273 degrees and boils at 373 degrees. So we're just adding our Celsius to it. So if we want to calculate this, so we take water freezes at 273 and then we add 100 degrees. So this is Kelvin and in Celsius, and then we add 100 to it. So we get 373. Temperatures measured using thermometer, right? So Kelvin, Kelvin also talks about minus 273 degrees, or 0 Kelvin. 0K is where it's called absolute value, absolute temperature. All right, so let's do this one problem here. Okay, so Kelvin is commonly used if 0K, no movement. The body temperature is 37 degrees, so we're going to take Kelvin at 0, where the body, that's where this is its starting point of 0 degrees, right? And then we add 37, so 310K. So what's the temperature of 16? So we're going to do 273 for the start of the, for what we call the freezing point, and then we add 16 degrees to it, right? So we add 16 degrees to it in order for that to work. So I got one person got it, 273 plus 16. Can anybody do that? Thanks, Gabby. Thanks, Rachel. Chloe, Aaliyah, thank you. Get in there. Dylan, thank you. Anybody else? Thomas, Sophia, 273 plus 16. What do you got? Grace, anybody? So we got 6 people. All right, so 289. Okay, so you have an exit quiz today. Let me get that for you. So I'll give you that link. So in the course module, you cannot see yet, but you will look here. All right, in week 11, you have the notes, right? Thermal notes, and you also have text-to-speech notes here, right? And you have, so Thursday, you'll notice we have 2 bonus assignments here, so to keep you going. I broke down the assignment week, assignment 1 as a normal one for 10 points for assignment 1, and then assignment quizzes for 5 points. So this one kind of, they combine for your 15 points this week. Here is the exit quiz. I'll give you this. This is open until Friday this week. So this is a good time to try and work on that. See how you're doing. This is give you one shot at this, right? You might want to look at your video one more time or look at your notes, but let me see what you do on the exit quiz. There are 4 questions here. So this is your exit quiz. All right, so the exit quiz there. So go ahead and get that started. Tell me if you're having any problems with that. Let me clear this, hide this, go to default. So many of you, okay, I gotta stop that. That's what I gotta do. Okay, so many of you need to work on, let's see, W9, W10 assignment 1 and 2 were due on Friday. That became a 0. I did the zeros this morning, so that is, so they gave some people minus 30 points, so lowered the grade. So make sure you do W10 assignment 1 and 2. Remember, you can do that as many times as you want to get that 30 points, 15 out of 15. So if you don't get a 15 out of 15, try it again. Ask a question. I will open up a big blue button. So remember, W10 quiz is due today. So make sure you get that done so that you don't getting things done before their due date is really important. Okay, and I have to grade that one anyway, so I know when you, if you take a look at the, when you get that one done, take a look at the notes that I give you. I give you some hints on how to finish that one, and resubmit. All right, you have 2 times you can resubmit that. All right, so there you go, have it. I will get the big blue button set up for you guys right now. So if you have any questions about anything in the class, where you are, what you need help on, come and see me. All right.